Hey everyone, in this video we're going through some application style questions for matrices. Now it would be a really good idea to do these before watching the video just to see how you go, because you have now up to this point learnt all the skills you need to do these questions. So if you're just copying down the answers and not really thinking for yourself, you might not really learn much. I think you would probably learn more if you did it on your own and really tested your own understanding before watching the video. All right, so let's get started. I think it might be a bit of a long one, but obviously by the time you're watching this, you will know how long it goes for. I'm going to aim for 30 minutes. Let's see how I go. All right, question 3. Each week, the coach of the Little Clunkers cricket team awards the best batter to the player who makes the most runs. The results of their last game are shown in the table. Cool. So we've got the players here, single runs, fours and sixes. I don't know how cricket operates, but there we go. We've got single, which I assume is worth 1, fours I assume is worth 4, and sixes I assume is worth 6. All right, write a column matrix W to represent the 3 different ways of scoring runs. So this is going to actually take me a bit of time to do part A, so I'm not going to actually do it all because we want to keep under 30 minutes, don't we? So we want to define it as W, so we do have to write W equals. And we want just a column matrix to represent the 3 ways of scoring runs. So represent the 3 ways of scoring runs. Okay, so we've got single, fours and sixes. So single, fours, let's just write single because we've got 2 S's, fours and sixes. All right, I don't think we can put anything in there unless we got 1, 4 and 6. So the different ways of scoring runs. All right, let's see how we keep going. We might have to use that in a sec. Write matrix R to represent the data in the table. So R probably stands for runs. So it's just all this data in the table. I'm not going to put it all in there because that would take an extremely long time. But we've got 1, 2, 3, 4, 5, 6, 7 rows. So it's a 7 by 3 matrix, which will probably come in handy very soon. Remember, the order is somewhat the most important thing in matrices. All right, I know I've got all these lines there, but I need to see the questions at the same time. All right, use matrix multiplication to find a score matrix that represents the total runs run by each of the players. All right, so singles is worth 1, fours worth 4, 6 is worth 6. So this is a 3 by 1 matrix. So 3 rows, 1 column. So when we're doing our multiplication, remember the order matters. So I'm just going to highlight this 3 has to match with this 3. So with our order, it has to be a 7. Hello, very thick pen. Let's go back and choose a different one. 7 times 3. And then 3 by 1. Because remember, these have to be the same. And then our product matrix will be a 7 by 1 matrix. So if we're doing 7 times 3, that's our matrix R. And we're going to multiply that by W to get matrix S. All right, so S is a 7 by 1 matrix, also a column matrix. All right, so we're going to use matrix multiplication to find a score matrix that represents the total runs made by each of the players. Okay, so on our calculator, let's put matrix R in. So remember, we're doing R times W. So R is a 3 columns, 7, 1. Oh, gosh, hold on. Got a bit carried away there. What are we doing? Why are you doing that? Let's start again. Come on. Okay, so 3 across, 7 down. All right, I've got 1, 2, 3. There we go, 7. 1, 2, 3, 4, 5, 6, 7. All right, 26. 5, 2, 12, 2, 0, 18, 7, 9 2 0 30 3 0 5 0 0 and 3 0 0, and we're going to multiply that by W for 146. So 146, and there's our total runs. So Hessian got 58, Sam 20, and so on. So when you think about it, a single, Sam's probably going to be easier to do. So Sam got 12 single runs and 2 fours. So 2 times 4 is 8. So 8 plus 12 gives us 20. So matrix S, let's just do that over here, was a 7 by 1 matrix. And I don't know whether I'm going to fit all the numbers in there. So 58, 20, 58. Where are we? 17, 42, 5, 3. All right, which player won the Best Batter Award? So I'm just wondering, because we got 2 on 58. That is a little bit annoying. Who makes the most runs? So I had Hessian and Ahmet. 18, let's just check. 18 plus 7 times 4 plus 2 times 6, 58, okay. 26 plus 20 plus 12. All right, so they both got 58. No one got higher. Vishnu didn't get higher. No. All right, so I think I've done it correctly. So which player won the best batter? Well, it's got to be Hessian and Ahmet. If we're going by who got the most runs. Oh, single runs? I actually don't know how cricket works. So if it's the total, yeah, Hessian and Ahmet. All right, which player? All right, going on to question E. The opposition team made 207 runs. Did the little clunkers win the game? All right, so we're just going to total it up. So we can sum it if we want to. Just go edit, copy. All right, so if we're doing a summing matrix, so this is a 7 by 1, so we can multiply it by a, what would we do? Let me just think. We want to sum our columns. We want a summing row matrix. So this is in your notes. I just had to think. There we go. So we want a 1 by 7. What have we got? 1, 2, 3. 1, 2, 3, 4, 5, 6. One more. 7. So if you had to show working out, let's say for your SAC or something like that, you would have to use a summing matrix. So we've got 203. Did they win? No. Sorry, clunkers. You did not win the game. All right, question 5. A chemist purchases small bottles of vitamin C tablets for $2 each and large bottles of vitamin C tablets for $3 each. In the last 2 weeks, he purchased the number of vitamin C bottles shown in the table below. So let's just highlight these things. So vitamin C tablets, $2, oh, small, and large is 3. All right, so small is $2 and large is $3. All right, find the 2 matrices that can be multiplied to give the total purchase of the cost of vitamin C bottles in each of the 2 weeks and complete the multiplication. So we can just put this as a 2 by 2 matrix. So 75, 60, 47, 82, and we can call that matrix C, maybe C for vitamin C. And then we've got the purchase price, and we might call that matrix P. So that is going to be 2, 3, and it doesn't have to be a column matrix. So what do we actually have to work out? We want to find, to give the total purchase cost of vitamin C bottles in each of the 2 weeks. So we want to sum our rows. So to do that, we do need a column matrix. So we've got a 2 and a 3. So when we do C times P, we're going to, and I might actually draw it so I can show you a little bit easier. So 75, 60, 47, 82, and then 2, 3. So we're going to multiply this week by these prices. So we're going to have 75 times 2 plus 60 times 3 in the first spot, and then 47 times 2 plus 82 times 3 in the second spot. All right, so that'll give you the total for week 1 and week 2. You can just do that on the calculator. You can do this on the calculator, or we can do that. Probably take you longer to do that, so just do it with the matrices. The chemist sells goods at a 75% markup. So that just means how much they're going to increase it by. He recorded his purchase costs over the last 2 weeks for vitamin C tablets and the 3 other items in the following table. So do we need to put vitamin C in there? Represent the cost as a 4x2 cost matrix. Using scalar multiplication, represent the selling price of these goods in a 4x2 matrix S. Right, represent the selling prices. Just need to work out what it's actually asking us. The purchase costs. Okay. So all right, so we need to actually work out this answer to put it in here. So let's do that. All right, so 75, 60, and then 2, 3. Oh, not 2, 3, sorry. 47. This is actually the 3rd video I've done in a row, and I've got a cold, so excuse me if I make a few small errors. All right, so 330, 340. All right, so 330, 340. All right, so if it was a 4x2 cost matrix, so, oh gosh, I think I just leaned on the computer too much. There we go. So we're just putting this information basically in a matrix, a 4x2. So we can just transfer that straight into that matrix. Using scalar multiplication. So that what that means, remember, is multiplying the whole matrix by one number. Represent the selling price of these goods. So it's being marked up by 75%. So when you have a markup, or which is the same as an increase, it's 1 plus your percentage, so 75 over 100, which will give you 1.75. So when you're doing your scalar multiplication, it's 1.75 times matrix S. And remember, this was, oops, sorry, not matrix S, matrix C. So this was matrix C, which came from there, and this is what matrix S is. So on our calculator, we can do that. So we're going to do a 4x2. All right, and that's our matrix. We're going to multiply it by 1.75. So 1 because we want the whole amount, and then the 0.75 because we're increasing it by 75%. So 0.75 is the percentage. And you get something like this because I have it on standard. So we're just going to change that. And so we get our decimal equivalent. Now, this is the new sale price. So this is matrix S. Now, if we want the profit, so the profit is just the difference between your sale price and your cost price. So we can highlight that, just drag it down. If this was on a sack, you would actually have to write this, but I'm just trying to be conscious of time in the video. And there's our original matrix. So it's matrix S minus matrix C. and that's our profit. So just the difference between the two. If we wanted to do the total profit to be made if all goods were purchased over these 2 weeks are sold. All right, so we're going to have to calculate the total profit to be made if all goods, so we have to add everything up. All right, so we want to, over 2 weeks, I wonder if we just, if we're just doing it for each product, calculate total profit to made if all goods were sold over these 2 weeks. So we want to total, I'm interpreting that, we want to sell everything. So that's our profit. If we want to sum our columns, so if we want to do week 1 and week 2, we do a row matrix. So it's going to be a 1 by 4 row matrix. So this is going to give us the total for each week. So week 1, there's your total, week 2, and then if we wanted to sum them, we're just going to do a column summing matrix to get the total. So we can't do it in one go. So we've got a row matrix, or you could do it in one go, but you just have 3 matrices. So we can put that one down here. Oops. Where are we? It's not cooperating. Come on. All right, let me just copy it. Dragging it down. All right, and then we can multiply it by this column matrix. So you can do it all in one go, but I just wanted you to see that you've got your 2 separate weeks, and then we're adding the 2 weeks together. So in total, it's $2,655.75. Now, if you're just writing that answer, you're not actually having an understanding of matrices, and in your SAC, you do need to know how to get this final answer through matrices. So one way of doing it is summing your columns. So we did the sum of week 1, week 2, and that's what we got for both of them. And then we had to sum that row. So we have to multiply it by a summing column matrix. All right, so you can copy that down in this space. All right, moving on to question 6. So the cost of fruit at a stall in dollars per kilogram is shown in the table. Sean wants to buy 2 kilograms of apples, 1 kilogram of pears, and 3 kilograms of bananas. Which one of the following matrix products will result in a matrix that contains the total cost of Sean's fruit? So we've got these values here, the cost, and we want to add them all up. He's got 2 kilos, 1 kilo, 3 kilos, and we're just going to make sure it's in the same order, which it is, which is awesome. So we can do 2, 1, 3 times this matrix, 250, 320, 190. So when we do that, it'll be 2 times 250, 1 times 323 times 190. But we're just going to make sure that is actually one of the options. And it is, it's A, which is good. Otherwise, we'd have to go through and check them. Another way you could do this, and you could actually think about this during reading time, is your orders. So I keep emphasizing how important it is to have an understanding of orders. So if you're doing a total cost, you want a 1 by 1 matrix. All right, you just want one number at the end. So we can't actually multiply B because B is a 1 by 3. And sorry, this matrix is a 1 by 3, and this one is also a 1 by 3. Can't be multiplied. This is a 3 by 1. And this is a 3 by 1, can't be multiplied. So even if you didn't understand how to get the answer, although it's not an overly difficult question, it's question 2, which is, when it's at the start, it's an easier question. This one here, we've got a 3 by 3 and a 3 by 1. So we can actually do the multiplication, but we're not going to get the total cost. What we would actually get is the cost of the apples, pears, and bananas separately. And here we've got a 3 by 1 and a 1 by 3. So that's going to give us a 3 by 3 matrix. All right. So even if you just knew how to work your orders, you could understand that A was your answer. All right, question 7. There are 2 rides called the Big Dipper and the Terror Train at a carnival. The cost in dollars for a child to ride on each ride is shown. 6 children ride only once on the Big Dipper and once on the Terror Train. The total cost of the rides in dollars for each of the 6 can be determined by which of the following. So 6 children ride only once on the Big Dipper and once on the Terror Train. We want the total cost. All right, so let's just think of our orders. So this is basically not going to give us just a total. This one's going to give us, so if it was kind of like a scalar multiplication, what is that, a 1 by 1? You can't even do that, 2 by 1. Here we've got a 1 by 1, but it's going to be a 1 by 2. Here we've got a 1 by 2. And this is a 1 by 2, so I can't even multiply them. And then we've got a 1 by 2 and a 2 by 1. So D is going to be our answer. When you think about it, we're going to do 6 times 7 plus 6 times 8. And here we've got a 2 by 1 and a 1 by 2. Also an early question, so not an overly difficult one. Very similar to the previous one. All right. The target in a game is a circle divided into 3 regions, inner, middle, and outer. The diagram shows these regions in the number of points awarded for hitting each region with a ball. So inner is 8, middle 3, outer is 1. The number of inner, middle, and outer regions hit by Mustafa and Neville in one game is shown in the table. Neville was the winner of the game. Well done, Neville. Which one of the following matrix calculations shows the difference between the winning and the losing score? So obviously we want Neville first because he won. So if you're doing the difference between 2 numbers, you put the higher number first. Alrighty, so what have we got? So we're going to have to put Neville first. So we do want 5, 9, 7, 6, 7, 2. So we don't necessarily need to do that because we're not totaling anything, so we probably don't even need a matrix with that. All right, we're going to look at them separately. So Neville is just 5, 9, 7, and if we're working out his score, that would be multiplied by, so inner is 8, so 8, 3, 1. All right, so that's Nev. And then Mustafa is 6, 7, 2 times 8, 3, 1. Now I doubt that is one of the options. So let's see what actually will give us the same thing as that. So we can see what we've got in common is the 8, 3, 1 matrix. All right, and we're subtracting them. So if we take out the 8, 3, 1 as a common factor, and the order does matter, so I'm going to do 5, 9, 7 minus 6, 7, 2. All right, so that's going to tell us the difference between inner, middle, and outer between Neville and Mustafa. All right, and then once we do that, we can multiply that by 8, 3, 1. All right, so even though the first one wasn't there, we can go on and think about, well, how else can that look? Let's have a look at it so it's clearly see. So looking at your other options here, so this is when we subtract these, we're going to get a 1 by 3 matrix, and this is a 3 by 1. But when we multiply them, we're going to end up with a 3 by 3 matrix. So we just want a single number. All right, the next one, because we haven't got brackets around here, it's actually only going to multiply this part by 831. So that's why that one doesn't work. This one here, why maybe the order. So subtracting that, let's see what we get. So it's a 3 by 1 and then this is a 1 by 3. So it would end up with a 3 by 3 matrix again. And this one here can't do the order. So, oh, actually, you can do the order, but we do end up with 3 by 3 matrix. So the only one that gives us a 1 by 1 matrix is option C. So again, understanding orders just makes so much difference to your understanding of what is actually happening with your different responses. All right, let's see how we're going for time. Oh, all right, let's just do these two questions. We're going to go over 30 minutes, but it's all good. All right, students in a music school are classified according to to 3 ability levels: beginner, intermediate, and advanced. Matrix S0 represents the number of students at each level in the school for a particular week. How many students in total are there in the school that week? So 20, 60, 40, that's 120. If you had to show that using matrices, you would have to use a row summing matrix. So you can go back to your theory for that. The music school has 4 teachers: David, Edith, and Flavio, and Jeff. Each teacher will teach a proportion of the students from each level as shown in matrix P. All right, so David has 25%, Edith 50%, Flavio 15%, and Jeff is 10%. All right, the matrix product Q times S0 times P can be used to find the number of students from each level taught by the teacher. We still haven't got to the question. Copy and complete the matrix Q by writing the missing elements in the boxes. So it's told us that we're going to multiply S0 by P. It should be an easy mark. So should the previous one. All right, it's question 1, the very first question of matrices. Should be a very easy question. And then question 2, also easy. So we're going to do S0 times P. So S0, and the order doesn't change unless it tells you to. All right, so we're not going to make this column matrix a row matrix. All right, and then times, what is this? A 3 by 4. All right. Oh, actually, no, it's not. I was looking at the wrong matrix. Sorry, guys. We're doing matrix P. It's a 1 by 4. All right, 0.25. 0.5. I knew I wasn't on the right track when I was like, there's blanks there. All right. So we've got, all the numbers are the same, which is good. So we can just fill in the blanks. So we've got a 10 there. Oh, why don't I look at what the other one was? And then a 9. All right, should be an easy mark. How many intermediate students does Edith teach? So we've got to think about the position for intermediate and Edith. So actually we can just put them on. So B, I, A. So beginner, intermediate, and advanced, and then up the top. All right, so that was 10. We have D, E, F, G. So Edith, intermediate, is here. So she teaches 30 students. All right, the music school pays the teachers $15 per week for each beginner student, $25 for each intermediate, and $40 for each advanced. All right, so there we've got it in matrix C. The amount paid to each teacher each week can be found using a matrix calculation. Write down the matrix calculation in terms of Q and C that results in a matrix that lists the amount paid to each teacher each week. All right, so we've got Q and C. So we can't just go and create our own matrices. We need to do Q and C. So let's think about the order of Q and the order of C. So Q is a 3 by 4 matrix, and C is a 1 by 3. So obviously we have to do, write down a matrix in terms of C. Okay, so C times Q, right, to be able to do it. So C being a 1 times 3 and Q being a 3 by 4. So they're the same, so we can multiply them, and then our product matrix is going to end up as a 1 times 4 matrix. So we have to write down the matrix calculation in terms of Q and C. So that's just C times Q. You can write down those matrices as well. How much is Jeff paid? So doing that calculation. All right, so we're doing C first. Good thing about matrices is sometimes you can do, well, most of the time actually, you can do your answers without the matrices. And then you can just check your answers. So let's put this in. So 5, 10, we actually don't need to do all this because we just need to focus on Jeff, but anyway, 15, 30, 9, 6, and then 10, 20, oops, 26, 4. All right, so where's Jeff in this situation? He's last, so he earns $340. All right, and that is in that element there, 1, 4, in case you had to write the element. All right, just past 30 minutes. Let's see how we go with this one. All right, the Westhorne Council must prepare roads for expected population changes in each of 3 locations, so main town, villages, and rural areas. The population of each of these locations in 2018 is shown in matrix P 2018. The expected annual change at each location is as follows. So this is your M, your V, and your R, all right, which is also written here. Write down matrix P 2019, which shows the expected population in each location in 2019. So we're going to have to multiply. Just trying to think what the next part is. All right, we have to go and multiply by these things here. So we want P 2019 has to be a 3 by 1 matrix. So we're going to take 2018, P 2018, and multiply that by, which is a 3 by 1. And if I multiply it by a 1 by something, which is what I would have to do, I'm not going, 1 by, no, can't do a 1 by 1, silly Billy. So we're going to have to do it at the start. So this is a 3 by 1. So we can do a 3 by 3. Okay, because we want this to be a 3 by 1 matrix. So to make sure we can multiply them, those two numbers have to be the same, and then the outside numbers have to equal this product. So that means the matrix that I'm multiplying it by is a 3 by 3 matrix. So we're going to have big 3 by 3 matrix. Now when we were doing those previous questions, we just wanted a single answer. So if we were totaling something, remember we just wanted a single answer. For this one, we want the total of the 3 different towns, all right? The expected population in each location. So not the total population, we want the population in each location. So when we do that, we actually do a diagonal matrix. So for main town, villages, and rural. So for main town, it's increasing by 4%. So we're going to do, so if it's increasing by 4%, we do 1 plus 4 over 100, which is 1.04. So that's what goes here. Then we're not going to multiply the other 2 towns. All right, so we're just going to have 0 there. The 1.04 only applies to M. All right, then for villages, we want to decrease by 1%. So because we're decreasing this time we're minusing 1 over 100, so we get 0.99. So 0.99 and 0 elsewhere. All right, so we're only wanting a diagonal matrix. For the last one, we're decreasing by 2%. So think of your phone battery. If it decreases by 2%, you're left with 98%. So 0.98. All right, 0.98. You can also do this on your calculator. We did it a lot in financial. So Yeah, so we're going to multiply that by 2018. So this matrix up the top here. So 2, 1, 0, 0, 1, 8, 0, 0, 1, 7, 0, 0. And we should end up with a 3 by 1 matrix. All right, so 1.04, 0, 0, 0.99, 0, 0, 0, 0.98, and then we're going to multiply that by that column matrix. So 2, 1, 0, 0, 1, 8, 0, 0, 1, 7, 0, 0. And there's the total for 2019. So when we're multiplying matrices, just remember that we go across, then down. So the reason why we only do the diagonal is because we only want the m to be multiplied by 1.04. So the 0, 0, so this 0 is going to multiply the 1,800, and this 0 is going to multiply the 1,700. All right, so we end up just with the 2,184. So if you're having to do the total of multiple things, you need to do a diagonal matrix like that. So I don't know whether we've done an example like this in class, so I would actually put this in your bound book because they do turn up a lot in exams, could also turn up in your SAC. All right, part B, the expected population in each of the 3 locations in 2019 can be determined by this matrix here, where F is a, write down matrix P 2019, which shows the expected population. Oh, I already did that. Okay, so this was, this is matrix F here. Okay, so we've already done that. Now I'm wondering what I was meant to do in part A. Write down matrix P, which shows the, okay, maybe you're meant to work it out without actually doing this calculation. All right, which we use that calculation to do it. It's a bit strange that they've separated it like that. Anyway, that's all good. So for part A, if you're thinking, well, how was I meant to do that? You can just take the value 2,100, which was the population in 2018, multiply that by 1.04, and then 1,800 times 0.99, and then 1,700 times 0.98. All right, didn't have to be a matrix, so you can just do it like that as well. Probably better to do it like that because it does ask for the expected population, so we shouldn't be leaving it as a matrix anyway. So when we do that on the calculator, we would get the same as this. All right, so I'll just show you with the first one, 2,100 times 1.04. All right, we get 2,184, and so on. Alrighty, I think that's the last question, just 8 minutes over, just a sneaky 8 minutes. We'll do transition matrices next term. Bye guys.